Welcome to the course Digital Transformation and Technological Innovation. So, we are into our fourth module, that is Tech Advancement and Internet Basics. So, let us continue the discussion from where we left. Now, in the last session we just started talking about taking an example rather to analyze the price performance across years. So, we decided to take a product, let us say Amazon Kindle, and idea is to analyze how the price performance curves or how price performance data had changed, and whether the fast cheap computing and other things that we discussed in last few sessions, how that can be observed in this particular data. So, we used generative AI to actually retrieve this data. So, there might be some rough approximations, but still it will help us create the picture, right. So, we have taken Kindle basic generation, that means the standard entry level models, and we have so that the comparisons remain more fair. So, we have taken only the standard entry level models of Kindle basic. So, let us look at this table. So, Kindle original version was actually launched in 2007, and if you look at the launch price, it is USD 399 and the base storage was 250 MB at that time. So, this was the first generation, right. Now, as we move from first generation to second generation, that is Kindle 2, then that got released 2 years later, Feb 2009, and you see a drop in the price. So, from 399 USD to 359 USD, and you see an increase in storage 2 GB. So, therefore, there was a price drop in 2 years. In 2 years there is a price drop, and we also see an increase in storage. So, storage got increased and the price drop. So, the people who could wait for Kindle 2, they they must have bought it at a cheaper price and better storage, higher storage, right. So, again this is reflecting what we already talked about, the phenomena of fast cheap computing and how that impacts the demand. So, therefore, because the price goes down and the storage is also significantly significant enough in comparison to the original version. So, therefore, more people would be willing to buy, right. And as soon as, even for the existing even the customers that were the original customers for Kindle 1 or original version, once the life of Kindle is over, they will also be looking to switch to a latest Kindle version. Now, moving forward, once we move from second generation to third generation, the Kindle to the third generation version was called Kindle keyboard, and it was released the very next year 2010, and now you see the sudden drop 139 USD, from 359 USD to 139 USD. That means economies of scale kicked in. That means this product was successful from first and second versions, and because of that higher demand for this, economies of scale might have kicked in, and because of that this reduction in cost, and obviously the fast cheap computing phenomena is obviously there, but there is too much of reduction. So, that can be attributed, there must be more than one factor apart from fast cheap computing, there must be economies of scale also that must have kicked in, and you can see the increase in storage also 4 GB, right. So, there also in this from version 2 to version 3 also we can clearly see the phenomena working here, right. Now, we move from third to fourth generation. So, in the fourth generation we see that no touch feature was added, and so rather it was no touch. So, there was touch version, and touch version was added, but that was into premium segment. So, the basic version still was no touch and keyboard only. So, this came in 2011. Now, again you will see a drop 79 USD, right. While the storage also was in the basic version, also it was dropped to 2 GB, right. But if we see other versions of Kindle, there also storage remain that, and then it is only later that this storage limit was actually changed. So, from here onwards, we can still notice that the price drop is there, though the storage was removed. So, still because of the significant price drop from 139 to 79 USD, still we can see that that phenomena of fast cheap computing working here. Obviously, economies of scale along with that, right, and storage there. Now, as we move from 4th generation to 5th generation, that is Kindle 5, this got released in 2012 and the price was 69 USD. So, this price was 69 USD and the storage remained same. So, you can see further drop. So, obviously, the demand would be there, economies of scale will kick in, but fast cheap computing phenomena, if you compare from first version to 5th version, from 399 USD to 69 USD, that is a huge drop. That is something that we do not see with the traditional products of physical traditional products in general. So, mainly applicable in computing products, right. So, this was 5th generation. Now, as we move towards so there was gap in a way, there was no 6th generation or it got merged with the 7th one. So, then from 5th to we move to 7th directly, and in the Kindle 7 version we see the touch upgrade. So, touch option was also there in the previous Kindle versions, but that was in the premium segment. Now, in case in from the 7th version onwards, the touch upgrade was there even in the basic version, right. So, this is the year release is 2014 and you can see 79 USD. So, the prices now you will see the prices if you compare these few generations from 7th to 8th and to 10th, again 9th got merged to 10th, right. So, you can see the prices stabilizing at 79 USD, storage also stabilizing. So, only the product is new features are getting added to the device. So, the performance is improving, but there is not much change that we notice in terms of price and storage. So, we can see things saturating here, right. So, Kindle 7 had touch upgrade, Kindle 8 was 2 years later 2016. So, might have been few performance improvement in terms of base storage and price, not much, pretty much same. Then we come to 10th generation, that is Kindle 10, and there is an integrated lighting, that was the additional thing. So, therefore, even in different lighting scenario it will work much better. So, this came 3 years later in 2019 and you see there is a slight increase in the price 89 USD and the storage remains same 4 GB, right. Now, from 10th generation when we move to 11th generation, so there was a display upgrade in the 11th generation. So, again it took 3 years 2022 and the price again for this upgrade the price was also slightly increased 99 USD. Now, the storage if you see now 4 times increase. So, while the price is slight increase from 89 USD to 99, but the storage 4 times got increased and there was a display upgrade also. So, 11th version again we see significant improvement with slight price increase, right. Storage and other display and other upgrades are much more significant when we compare to the slight price increase. So, there also again we can see the same impact happening here. Similarly, if we look at 12th generation which was 2024, so it basically is more like a Kindle 11 only, but with higher brightness and faster page turns. So, improvement of Kindle 11 and the price slightly got increased, storage remains same, right. So, the cost goes up towards the improvements in terms of brightness and faster page turns. So, if we look at the overall thing, if we compare from Kindle 1 that was 399 USD to Kindle 11 which is like 99 to 109 USD, we can clearly see the price drop and move in terms of storage 250 MB to 16 GB and then so many additional features that got added over the years, from brightness to faster page turn, display upgrade, integrated lighting, touch upgrade and all those different aspects. So, clearly as we move forward, production technology improve, fast cheaper computing phenomena applies, and in case of new products like Kindle when it was launched, in 2007, first two generation. The economies of scale also helped to bring it to bring down prices significantly, right. So this is one more modern example to understand this price performance curves for a product, and we can see how the technology advancement rate and the price elasticity, how that works in case of a computing product, right. Now let's take few more examples while this fast cheap computing phenomena that we talked about it and different waves of computing and how the new markets get added up. In all that discussion that we have had in last two sessions, we also talked about that even in the traditional physical products, the smartness of the computing is getting integrated or getting embedded, right. So we will take some of these examples where traditional products are getting replaced by smart versions of the same products. So we are taking the successful examples, mainly examples which survived. So many such products or product examples are also there where the innovation was there, and working prototype and everything was there, but it was not well received with the in the market. But here we are looking at examples which are still successful. So first one is Nest thermostat. So this Nest Labs was acquired by Google, and what they came up with, the smart thermostats. So what it does, it automatically and efficiently adjusts energy use at home. So therefore no one has to manually do it with limited bit of controls. Nest thermostat had the smartness to automatically do that based on the and adjust the energy use. So what happens, so how it does that, it has motion sensors to detect whether there is someone in the room, and accordingly if there is no one in the room then it can adjust the energy use. Similarly temperature sensor it has, so therefore it knows what is the desired temperature and how to keep it that level. And then the Wi-Fi, for Wi-Fi and other, obviously there would be, and OS also, and software part also would be there, Wi-Fi for networking capability, so that you can control this and the data transfer can also happen. So what was the benefit? Energy savings. So the households which will actually go for Nest thermostat, the energy consumption would be better optimized without and the convenience might also be much better, because you do not have to adjust and it does that automatically. So better ease of use, convenience, and reduction in the energy bills. So savings there because of the smartness inbuilt through sensors, motion sensor, temperature sensor, Wi-Fi and other computing components. So this is one successful example. And then moving on, another example that is mainly seen in Japan, where we see this, where there is a huge market that has grown up, and that market is actually about smart billboard market. So there are lots of people who walk around in Japan, so it connects to that culture, and therefore there is an opportunity for advertisers to display their ads. So these smart billboard market, so what this is about, it facilitates the smartness in the billboard that facilitates targeted advertising. That means you can switch the content instantly in real time based on the cars going through, and detecting the demographic of the car based on the car type. It might be luxury or medium segment or low segment car. So based on that you can use AI model, and it can be demographic can be detected, and based on that immediately in a real time the content or the targeted advertising can be switched, right. So this is smartness, including which has an AI component also, right. Similarly other people passing by, the content can be switched instantly. So that is also part of this smartness that gets integrated into the billboard market. Then another model that we can see is that impression based advertising, and so there are lots of billboards, traditional ones. So there would be a flat fee model. Traditional model for traditional billboard is flat fee model. So people want to display their ads, so that ad will be displayed and there would be a flat fee, right. So it could be traditional billboard, it could be physical also, it could be displays also, but here we are talking about the smart ones. So here because the computing or smartness role is there, so pay per actual passerby viewer rather than flat fee. So that computing can help detect whether there is actually passerby, and therefore an impression was made, and therefore the payment model, the revenue model would be pay for actual passerby viewers. So impression based advertising, something that we see in digital marketing. Something similar can be applied in case of billboard, because it is smart, so it can detect whether there is a passerby there and charge based on that instead of the flat fee. So therefore advertisers would be more willing to go for these smart billboards rather than the traditional billboards. Right. So these two models can be seen, and how all this is working. AI cameras inbuilt into those smart billboard, so that the detection of the car or other demographic can be done. Motion and gesture sensors if there is a passerby, for that, and high resolution LED display, so that better effect is there in terms of advertising display and all that. So other kinds of more engaging displays with 3D orientation and all that can also be achieved. Edge devices for content management and all that, there might be a bit of computing that might be needed. CMS is there, there might be content management software, and some sort of edge computing will happen at the billboard level itself or closer to the smart billboard. So that would be there. And the speakers to again give more interactive effect. So much of technology is being used in these smart billboards, and the main idea is to be able to manage the advertising, do targeted advertising or impression based advertising for the passerby, and whether it's car or pedestrian or others, right. Moving on to our next example, this is about smart license plate initiative of Dubai. So this is again for real time traffic monitoring with automation for various things that a government initiative might want to cover for. So automation for accident alerts. So smart license plate will have the sufficient computing mechanisms to detect the accident, so and then sound alerts for that. So accident alerts, theft prevention. So in case of some a vehicle getting stolen, so that same smart license plate can help detect that theft, and therefore prevent in a overall sense. Registration renewals, right, that can also be facilitated, because there can be a connection through that smart license plate that can happen. And then the reduction of parking fees, tolls, fines, that can happen, right. So therefore nobody has to go to the actual physical office to pay fine or register or pay toll, get down and pay toll. So there would be overall efficiency, traffic efficiency that would be seen, so not just the monitoring part. Then V2V information sharing, vehicle to vehicle information sharing through these smart license plate and the connectivity that is there in those smart license plate, that is feasible. So therefore if there is any hazard that is there, then other vehicles which are behind, information can be shared with them. So that V2V information sharing is possible, right. Now what are the computing components, how the fast cheap computing is facilitating. So obviously if it was not cheap computing, these kind of these kind of solutions, these kind of initiatives won't be affordable, right. So the affordability is coming from the cheap computing that is there, right. So vistable digital screen is there, then CPU, because a bit of computing deductions are also happening, motherboard, and wireless communication, there is integrated SIM card. So then GPS for better location identification, connectivity with the internet for registration, payment of tolls and all that will be facilitated here, tracking through GPS, sensors for reduction in terms of collision or accident or other things. those sensors will play a role. RFID is also there, right. So that will also facilitate to check whether permit and other things are there or not. So all these different components facilitate different aspects of traffic monitoring and do a lot more automation. So how these kind of initiatives possible? So the same phenomenon that we have been discussing, fast chip computing, right, and because of that all these kind of initiatives can be seen. They become affordable at a larger scale, because managing a real time traffic in an automated fashion using all these computing components across so many cars. There would be so many smart license plates for depending on the kind of number of cars that are there in a city, right. So therefore it's large scale initiatives, and only because the computing has been getting cheaper, these kind of initiatives become affordable. So then in the same initiative, there are AI powered devices across the city to automatically scan license plate. Now it's a smart license plate, so therefore this automatic scanning can be done, and that's how the traffic can be monitored. So real time verification of payment, permits and other things, that can be facilitated through these AI powered devices, right. Now next example is smart pill bottle from Adhere Tech. So this now connects us back to the medical domain, right, or healthcare domain. So what is the benefit? Benefit is improving medication adherence. So there are some serious patients or serious diseases, so their medication adherence can be a problem, because patients themselves might not be in a position to manage their medication schedule. So medication adherence and patients engagement in real time, that can be facilitated through this smart pill bottle and with the a little bit of computing components. So what is the computing component? Built-in cellular chip. So what this chip will do? It will transmit data automatically without an app or a smartphone. So therefore whenever that pill is opened, the data transfer will happen, and therefore a log can be created or the adherence could be monitored. And so essentially through this data and adherence boosting platform is also there. So through this pharmaceutical firms they can benefit in a way, because if patients are able to follow their medications, right. So if patients are able to follow their medications, there is a financial incentive for pharmaceutical firms. So why this model is successful? Because of this financial incentives, because of the better medication adherence, there would be timely filling of the bottle and timely orders for the pills, right. So therefore pharmaceutical firms will gain. So they have an incentive to keep patients on medication, and therefore the smart pill bottle is something that they would like to sell to their patients, because they gain through more sales of pills, right. So overall notification and other mechanisms through this cellular chip can be managed to improve in case a patient is patient misses a particular medication, particular time slot in the schedule, then there can be notification, people can come and help and do that. So overall medication adherence can increase, patient engagement can increase. Now another example for the medical industry itself or healthcare is pill cam. Now this is more something that is more useful for the doctors while they are trying to diagnose the problems, right. So pill cam actually helps in terms of visualize and monitor digestive tract areas that are difficult to actually reach with traditional endoscopy. So specifically the small intestine. So there the traditional endoscopy, it might be slightly difficult to reach those areas and therefore visualize and monitor the situation and what kind of cure would be needed. So pill cam can reach there. It's a small small pill sized device which has the inbuilt camera, right. So you can see there is a pill, and what is there in the pill? CMOS image sensor. So this is the one which will actually do the imaging, and LED illumination, so that to support the imaging itself, because there would be dark patches, and then motion sensor. So because the movement of the pill is fast or slow, and adjustment to the frame rates that are being taken in that imaging. So, that can be done through motion sensors, silver oxide batteries to power it up, and then ASI ASIC transmitter and antenna to transfer that data by data to a transponder, adhesive transponder attached to the patient body. So, all the imaging data that is being captured by the pill, it can be transmitted to this adhesive transponder, and there are which can have its own computing elements, for example built-in vibrators, speakers, and LED indicators, USB-C port to take back all that data to the computer and the software for the analysis of the images and all that. So, through this better monitoring, visualization and monitoring and diagnosis of digestive tract areas can be done, especially for especially for the places parts internal parts which are difficult to reach by traditional endoscopy. Now, in terms of software applications, what are the components? So, software applications would be there to manage setup, QR code scanning, instant kit pairing. There are two components, one is adhesive transponder and then the pill is there. So, that pairing has to be managed. And then live feed. So, live feed of the capsule's location. So, where is the capsule? So, doctors would like to see that whether it has exited the intestine or not, and so that live feed of the location of the capsule is important. And then compilation of images, once all the image data that is there, compilation of that into video, and that can be connected to the cloud for better analysis, better storage. So that right. So, all these software components would also be there, and overall it will help in terms of better monitoring and better diagnosis, visualization, monitoring, diagnosis of diseases there. Now, how all these examples are possible? Again, same fast cheap computing, and because these computing components become cheaper, therefore you can start integrating or start embedding them into all kinds of devices, all kinds of use cases with the medical, traffic, right, and advertising, right, and house energy use, right, house hub. So, all these kind of use cases we can see clearly here. Now, moving on, now we move to our next question, that is about what are the limitation of tech advancement, right. So, with every successive generation, what is happening in the silicon chips with every successive generation. So, it reduces the distance between pathways, right. So, every advancement in each successive generation of silicon chips reduce the distance between pathways. So, pathways within the chips. So, chip pathways are getting reduced, and so what is happening, electrons travel shorter distances, right, and because of that chip performs faster, right, and so continuous improvement, the speedy silicon chips that we get in every successive generation, that is because with the advancement in the production technology, these pathways are getting reduced. So, electrons in a way we can say that travel shorter distances and chip performs faster, right. But there is a, while this same packing of more transistors and reducing the pathways is actually improving the chips, making them more speedy, but then eventually there is a limit to this improvement. So, we keep on continuously packing pathways, right, in a dense manner tightly together, and we are doing this to create better chips, but eventually there would be problems linked to size, heat and power, because you keep on packing pathways, eventually you will run out of further gaps to fill in, right. So, once that happens, there would be problems that you run out of all the size, there would be size limitation that will kick in, there would be more heat, and then to dissipate or to manage that heat, you will need to cool it down. So, therefore, more power. So, let us look at these some of these factors. So, when we talk about densely packed electrons, so they will heat up the chip. So, what will happen? Pathways get reduced because of the dense packing. So, because of the size issues, the heat up, overheating or heating up of the chip will happen. So, then these powerful chips, they will be cooled down to prevent melting or overheating, right. So, there would be their additional cost to keep that speedy chip working, and that causes cooling bills, right. So that speedy chip does not melt or overheat. So need to cool fast computers draws more power. So therefore, we will have to supply more power for cooling regions. So that is why you see fans for PCs, laptops and video game consoles. So that the extra heat that is getting generated, that can be thrown out. And ACs and venting system we see for data centers, right. So why all this is there? Because there is so much of heat that is getting generated, and these speedy chips, if they are continuously on 24/7, then there is more chances that the melting and overheating can happen, and therefore we need to cool them down, and there will be cost to the power. So the size is linked to the heat. Size in the sense how many transistors we are packing to the chip, pathway is getting reduced, and because of the heat, more power that is it will take because of the cooling needs. So chip pathways cannot continue to get shorter forever, right. So therefore, eventually there would be a limit to this tech advancement rate because of the reduction in chip pathways. We are reaching the limit. So if we do further packing, there is another phenomena, quantum tunneling phenomenon, that may occur. So essentially what this phenomenon is about, electrons might start to slide off their paths. So therefore the whole communication, traveling of electrons, and that 0 and 1s, those two states that we manage through this electron movement, that might not remain reliable because electrons will start to slide off. So therefore there is a limit to this tech advancement, there is a limit to this dense packing of transistor that we do for chips to make them speedier. And so then what is the way forward? How do we keep on getting the performance improvement based on the hardware, based on the chip and other computing components? So then obviously we need to innovate with the chip designs, right. So we will talk about some of those design changes, chip design changes rather, that have been achieved, and we will discuss them in the next session. Thank you.